We'll start with Matilda Nordman, a PhD student at the research group for nutrition, sustainability and health promotion. And Matilda will talk about deriving health and sustainable diets with the use of mathematical optimization.
Thank you, Sarah. I'm glad to see at least few people made it their way from the lunch over here, but hopefully some more will join after my presentation, of course. So we've heard something about plant-based foods today, sustainable foods, but sustainable foods will need to be integrated into a sustainable diet to actually count for something. So I'm going to talk a little bit about how we can derive sustainable and healthy diets using mathematical optimization. Sarah actually touched upon this in her presentation, or was it Ellen, about the different sort of dimensions that we consider in healthy and sustainable diets. Going beyond just human health and environmental sustainability to also account for acceptability and different social aspects. And I'm just saying this to sort of show that it can be quite complex. So when we create diets, it's hard to encapsulate all of these different dimensions in one reference diet. For example, when we create diets for food-based dietary guidelines, we need to consider a lot of different things. So for this, mathematical optimization is a tool that we can use, and I'm going to quickly demonstrate how that works. So as a starting point, we have a reference diet or a baseline diet. In my case, that reference diet is the average Danish diet as it currently is. Then in our optimization, we have an aim. So we try to, for example, keep the diet as similar as possible to the current diet while fulfilling different constraints, so different conditions for what we want this diet to do. So with other words, we try to minimize the deviation from the current diet to our optimized diet. And this we can define as a mathematical function that looks like this. It just says that we are minimizing the sum of the quadratic relative difference between the optimized and the current diet. So that's our aim. And then we have different constraints that need to be fulfilled. So for example, the diet needs to be nutritionally adequate, meaning that it needs to contain all the different nutrients, macro and macro, that we need to sustain health. There may be some health constraints because we know from epidemiological evidence that certain foods are associated with positive health outcomes. So for example, we want people to eat vegetables and so on. Then we may have some food culture related constraints. So for example, we don't want to maybe completely remove the beer from the Danish diet and so on. This we can also steer by constraints. Oops. And then importantly, we need to have a lower environmental impact of the diet. So in this case, we were trying to optimize a diet that had 30% less greenhouse gas emission. Now I realize that I already clicked out all the rest of my animations here, but it doesn't matter. So these constraints we can formulate also as mathematical functions, and then we put it into a system of functions that we solve with an algorithm. So we apply this optimization algorithm and we get a new optimized diet. And here I'll show you some selected results from the optimization that I recently ran and published. So compared to the average Danish diet, which is in red bars, it's probably too small for you to read, but it doesn't matter. The kind of main points of this diet is that the starchy products are more than in the average diet, and also vegetables, quite a bit less meat, but some meats are still retained in the diet. But I think it's boring to look at diets in bar plots. So I was thinking, how does this diet look like in real life? And lucky for you, I was curious and did this of measuring and actually laying out all the foods of my mathematically optimized diet. So this is all the foods for 5 days for an average adult woman, me. And you can see that it's quite heavy on the starches, also vegetables, so lots of plant-based foods. But there's also room for a fair bit of animal kingdom food, so a little bit of meat and dairy and fish and stuff. A tiny little compartment for the discretionary foods also. I was lacking a bit of beer there by the end of the week. So some future perspectives and next things we want to look at. We know that one diet probably is not sufficient for every individual in the population to be recommended for. So what we're trying to do now is look if we can cluster our population into some different types of diets. So for example, somebody who eats more meat and less vegetables and so on. And then we take that as a starting point in our optimization and see if we can in different ways make diets that are sustainable and healthy. That's at least the idea, but let's see how it goes. Thank you.